This is the Hooke's Law activity introduction video. This is a pretty simple lab. Some of you may be familiar with Hooke's Law. Hooke's Law says if you have a spring that's just sitting there, minding its own business, it's not stretched at all, then you put a force on the end of the spring and stretch it. You can hang a weight there, you can pull it with your hand, doesn't matter. Then the force the spring pulls back with, not this force all the time, but the force the spring pulls back with is equal to K. So this is the force the spring pulls with, is equal to K, which is a spring constant. Once you find it for one spring, it never changes. It depends upon the spring. Now, from spring to spring, it can be different, but for one spring, it never changes. So if I take that K times the distance it stretches, then that tells me how hard the spring is pulling back. Now, if you hang a weight and you wait until the spring is not bouncing back and forth, then we have a balanced force. And the force of the weight will equal the force of the spring. And that's the case we're going to do in the lab today. We'll do labs where the spring is moving, so the force the spring pulls with will not always be equal to the force that's pulling on the spring. Now, one other thing we know is that, I'm not going to derive this, but I'm going to tell you that the work of the spring, the work you do on the spring, is equal to 1/2 times the K times the delta X squared. And so if I pull it down delta X, then I've done this much work. But we know the work has to go somewhere. So the work I do on the spring has to equal the potential energy in the spring. So I pull it down. If you let go of this force, then you have all that energy that you've stored up is now available to do work as the spring goes back up. So the energy stored in the spring is equal to the work you put in the spring, and so in either case it's 1/2 kx squared, and those are formulas that you'll use in today's lab. Good luck.